Beleza, galera? Todo mundo alimentado, bebido? Vamos para a nossa próxima palestra, então. Esteban Garcia is a cloud architect at mercadolibre.com. Welcome. Esteban will talk about microservices without servers. It's like black magic. All works.
Hi, good evening. My name is Esteban Garcia, and I'm going to be here to talk about microservices, and not the microservices we just seen here right here. Okay, great. So like I just said, my name is Esteban Garcia. I work at Mercado Libre, the #1 e-commerce in Latin America. For those who don't know what Mercado Libre does or what we do, Mercado Libre is the first tech company to be founded in Argentina and to be expanded to the whole Latin America. We have 3,200 employees. Every second, 6 purchases are made. That means that from the time I start speaking until now, about 100 purchases were made in the platform. We have 6 million unique sellers, 23 million unique buyers, and more than 2,000 searches per second. And what does Mercado Libre look like behind scenes? Mercado Libre works with a microservices architecture. We have more than 6,000 applications working in our infrastructure. We receive more than 28 million requests per minute in our APIs and frontends. We have more than 23,000 virtual machines running on top of OpenStack on more than 1,600 physical servers in 2 data centers, both in Virginia and Atlanta. And recently, we started using the public cloud. And right now, we have more than 4,000 servers running on EC2 in AWS. But let's start talking about the topic that brought us here, microservices and the serverless approach. Let's first start by talking about microservices and the difference between them and the monolithic approach. Let's say that we are a new startup and we start to develop a new e-commerce service, let's say. At this point in our company history, we most likely be more worried about creating our application and developing than be worrying about deployment, microservices, and a lot of things that aren't useful for us now. And that's fine. There's nothing wrong about it. There's nothing wrong about this approach. Every major internet company in the world started with this approach. Mercado Libre, Netflix, Amazon, you name it. At this point in our life, our application will be simple to deploy because there isn't much code. It will be simple to develop. It will be simple to scale. You can just create new services with different copies of your application behind a load balancer, and everything will work. So far, we are really happy about how our application is working. We are really happy with our monolithic approach. But time passes, our startup starts to grow, our business starts to grow, we start to hire more developers, our team grows, we start to organize our company differently, and we start to create teams inside our company that deals with different aspects of the platform. For example, we have a team that takes care of the front end. We have a team that takes care of the search capability of our e-commerce. We have a team that takes care of shipping, items, etc. And here's when we start to have some issues with this approach. First of all, the trouble with a monolithic application at this point is that it prevents teams from working independently. Each team will have to coordinate with each other in order to be able to coordinate their deployment efforts and redeployments. At this point, our source code has been growing exponentially, and it starts to intimidating developers, and mainly the new developers that are starting in our team. The application can be difficult to understand, can be difficult to modify, and as a result, deployment typically slows down. And if that happens, that means that there are no new features in the platform. That means that business is not happy. Another reason is that continuous deployment starts to be difficult. A large monolithic application like the one we're starting to have is an obstacle to frequent deployments. In order to update just one component of our application or to introduce one new feature, we have to redeploy our whole application. And let's say that we're deploying 5 new features, and one of those has a bug, then our whole application could go down. As a result, because of this, there is a risk associated with redeployment. And this discourages frequent updates in our application, and that means that new features are not coming to our platform. This approach requires a long-term commitment to a single technology stack. For example, let's say that we program our e-commerce using CodeIgniter. I'm sure that a lot of you know that framework for PHP. And that framework started to get old and start to get replaced by new and exciting technologies, like, for example, Laravel. Great framework to work with PHP. Ooh, Laravel. Let's say that now we want to get off CodeIgniter and go to Laravel. We have to redevelop our whole application. That means, again, the same thing. No new features start to come to our application because we start spending time in redeveloping our application instead of bringing new features that in the long run will bring more money to our company. And lastly, but not least, we have a centralized data management. Our application has just one database that it could be replicated, but it's just one. What happens if that goes down? Our whole application goes down, we have downtime. Even the features that don't require a database, they go down. Because most likely, the framework you're using, the first thing we'll do will check your database connection. So the first thing you'll get is PHP error. And here is where the microservices architecture comes into play. In a microservice architecture, each component is independent. And they are relatively small, and it's easier for a developer to understand it. Each service can be deployed independently of other services, and that's a great thing for your team, because you don't have to coordinate with other teams in order to deploy your service. The service is yours. Your team is in charge of it. You are responsible for deploying. If you have a problem with your service, your responsibility, and it won't bring downtime to the whole platform, just to your service. Another good thing is that you're not tied to a single technology or a single framework. You can take advantage of emerging technologies. For example, like I just said, if you want to go to CodeIgniter, to Laravel, you will just to redevelop that specific service that is using CodeIgniter instead of develop your application. Or you could use other languages as well. We have a decentralized data management. Like I said, each service is independent. That means that it will have its own database. And if that database goes down, then only that service will go down. And again, that won't bring us downtime to our whole application. It's easier to scale, easier to deploy. You can take advantage of technologies like Docker. It enables your organization as well to organize the development effort around multiple teams. And all the communication through your microservices will be done through APIs and messaging queues. Your service must expose itself as an API, and other services, if they need to use it, they will call that API in order to work with them. The usage of MQs is not mandatory, but it's something that you should consider. Mainly because since we have one database per service, we need to provide mechanisms to ensure data consistency between different services. Asynchronous HTTP calls can work most of the times, but depending on the size of your application, the size of your microservice architecture, the amount of calls that you need to do to each of those services to notify that something changed in another service can get messy and could slow down your application. Using messaging queues, you could do that in a way where you just post a notification to another service and that service consumes that message and does something with it. For a great example of a working messaging queue example, go to our stand in the lobby, where you could buy a coin using Mercado Libre, and that will post a message to our messaging queue system, and it will give you a coin that will be thrown to you using a Raspberry Pi. And you could use that to play Street Fighter. And lastly, but not least, in the long run, this approach can save you money. Maybe not in your AWS bill or Google Cloud bill, but being able for the teams to be independent of each other and being able to develop features more rapidly, that will give you money in the long term. Okay, so now our e-commerce startup implemented a microservices architecture, and this is how it looks like right now. We separated each function to an independent service. We have an API for users, an API for items, an API for payments, and an API for shipping. Each of those services takes care of a different part of our application, and if one of those goes down, then the whole application won't be affected. So if our shipping service goes down, for example, you will be able to buy an item, pay for it. Maybe you won't be able to receive it. Like you can see here, we have a new player inside. That's the API gateway. And since our application can be made of 1,000, 2,000, 3,000, or in the case of Mercado Libre, 6,000 microservices, we need to be able to provide our developers, or even third-party developers, a single point of entry to all of our APIs. That's where the API gateway comes into play. The API gateway has several benefits. One of them is that it insulates you from how the application is partitioned into microservices. It isolates you on the problem of determining the locations of those services. And it can enable clients to retrieve data from multiple services with a single round trip. That means that you will have fewer requests on your services. That means less overhead on your application. That means an improvement in the user experience. But, well, nothing is perfect in this life. The gateway has some drawbacks that you should consider. It will increase the complexity on your architecture, mainly because it's another part that you will have to develop, deploy, and maintain. And another thing is that it will increase the response time of your application because of that additional network hop that you will have through the API gateway. However, most applications, they won't care about that additional cost if they are fast enough. But it's something that you should consider. Okay, so when you start to think about microservices, there are several things that you need to start thinking about that you didn't before. For example, deployment strategies. How to fetch logs from all of those services and have it in a single way where you can browse them. How to manage multiple load balancers for each of those services. How to health check all of those services. How to create access tokens for authentication that all of those services will use in order to know which user called it. You have to administer multiple databases. But fortunately, we have the public cloud. And every major public cloud provider, such as AWS, Azure, or Google Cloud, will provide you with services that you can use in your favor to solve these issues. And each of these services have different levels of abstraction, depending on what you're looking for and what do you want to do. The serverless deployment approach, it isolates us from what we don't care right now. And what we don't care right now is about infrastructure. We just want to develop. Our startup needs new features. We don't need to take care about servers. And that's what we are going to see right now. Let's start talking a little bit about AWS Service Lambda. Lambda is a serverless compute service, and it runs codes, real code, in response to events, and automatically manages the underlying resources for you. Don't get me wrong, when I say serverless, that means that it's serverless for you, but there's still servers behind all of this. It's just that you don't care about that. The code that you run on Lambda is called a function. And like I said, it's triggered by an event. That event could be a lot of things inside the AWS ecosystem. Could be an S3 bucket, could be a DynamoDB, could be from Kinesis, could be from a queue system like a SNS, an email, API gateway, CloudFormation, you name it. Almost every AWS service can trigger a Lambda function, which is great because you can use this service to extend AWS services with our own logic. For example, if we have a user's API and a user registrate and it uploads a profile image for your service to use, then you could most likely can upload that directly to S3. And we can have an event that listens for S3 changes in a specific bucket. And that will trigger a Lambda function that can, for example, compress that image so you can save space. Another service that you could use to trigger a Lambda function, it's the one that we are going to speak about in a minute, it's AWS API Gateway. That service allows you to trigger Lambda functions on HTTP calls. The level of abstraction this service gives you for infrastructure is great, mainly because you are not interested at this point in knowing what's going on behind scenes. You don't have to worry about provisioning services, creating Amazon images. You don't have to worry about high availability because this service takes care of it. It will provision your code on multiple availability zones of AWS. Each availability zones, for those who don't know, are different data centers in the Amazon ecosystem. And you don't have to worry about load balancers neither. Another great feature is that it scales on demand. You could have millions of requests, and Lambda will take care of scale your code if needed. Lambda runs on top of containers, so if it detects that it needs to scale your application, then it will spawn a new container on a different service, on a different server. Also, Lambda takes advantage of CloudWatch and CloudTrail services. It's really important to have a really good monitoring and logging in your applications. CloudWatch and CloudTrail are the services that AWS provides for monitoring and logging. And it will provide you with metrics, for example, the execution time of your Lambda function, the load balancer response time and latency, the request amount that your load balancer is getting, and the error rate of your application. And one important thing here is that using this server, remember that you are completely isolated from what's going on behind scenes, so you won't be able to get much metrics from what's going on behind. And this is important because I know that most of you develop in PHP, but if some of you develop in Java, for example, you could have a memory leak, and you won't most likely don't know it because you can't see how much memory your application is using. You will have to use your own debug tools for that. No matter which cloud provider you're using, all cloud providers are offering this type of services. Something important is that these type of functions are intended for small workloads, which makes it great for microservices, which are intended to be small and work rapidly. For now, Lambda only supports Node.js, Java, C#, and Python. But there is a way to execute unsupported languages such as PHP, Ruby, or Golang. I'll give you a link later on how to do that. They will share this presentation with you so you can have it. And lastly, there is no out-of-the-box integration for continuous integration or deployment. That is something that you should take care of your own using other AWS services such as CodeDeploy, or you could even start using servers. Unfortunately, and spawn a Jenkins server. With a few scripts, you can easily start having a pipeline for your AWS Lambda functions. Let's talk a bit about Amazon API Gateway for a moment. So API Gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. It allows you to easily manage RESTful APIs. It can expose HTTP endpoints that are already existing in other cloud providers or your own infrastructure, maybe, as well as it can call different AWS services. You can, for example, provide an endpoint for downloading S3 files without the need of exposing the S3 links to your users. And you could also, like I said in the last slide, you could trigger Lambda functions, which is what we want. It also has a really good feature that it generates dynamically SDKs. When you create an API using API Gateway, you define all your resources, all your endpoints, and all the methods that you're using, and what to call on each of those endpoints. Because Amazon already has that information for you, you can easily create an SDK for Android or iOS, for example, that you can use in your own mobile applications to easily call your API. And using that same information, you can dynamically create documentation, which, by the way, all developers suck at it. Something important is that with API and with Lambda, you pay for each execution of the service. And with API Gateway, you also pay for data transfer out. For some people, this may be a drawback if you're thinking about costs and money, because it's an additional cost to Lambda. And it may be something bad for you. This is an example of how the workflow will be when you are using an API Gateway to call a Lambda function. You have your client. Your client calls an endpoint of your API/users in this example. This will go to AWS API Gateway Service. The API AWS Gateway Service will trigger the Lambda function that you configured in your API. The Lambda function will execute the workload you programmed. For example, it could get the record from DynamoDB. And it will send a response back to the API Gateway. And the API Gateway will be responsible for sending a response back to the user. And this is something I want to make clear, is that Lambda is not responsible for taking the response back to the user. Lambda just takes the response back to the AWS API Gateway, and from there to the user. So now our e-commerce startup has implemented a serverless approach using AWS Lambda. And here we decompose even more our services. Each of our services were decomposed into 3 actions, the 3 actions that each of these services had. Each of these actions are a separate AWS Lambda function. So in this example, if a mobile application user calls our API Gateway and wants to register a user, for example, the API Gateway will call the post user Lambda function that will process the request, create the user, persist that into our database, and send the response back to the user through API Gateway. Okay, now we just talked about AWS Lambda functions, but I would like to take a moment to also speak about their competitors. In this case, I'm starting with Azure Functions. And to be clear, each of the cloud providers, they provide the service, and overall, the service is the same. But what's changing are just some little things that could help you with user experience. And in this example of Azure, we can see that it supports more programming languages than AWS. It supports Node.js, C#, F#, Python, PHP, Java, Bash, and Batch, which is kind of cool. And another cool thing is that, and this is really weird coming from Microsoft, the runtime that uses Azure Function is open source. And this is great because it allows you to easily test your functions locally, which is not possible without any third-party libraries when it comes to Lambda. And another really great thing that Lambda doesn't have out of the box is deployment, like I said, continuous deployment. With Azure Functions, you have that out of the box, and it connects with every major source control provider that you can imagine. GitHub, Bitbucket, GitCloud. You can even use the Git provider that Azure gives you. Unfortunately, for now, the Azure's API gateway doesn't support Azure Functions, but it gives you one endpoint per function that you can call separately. And with those endpoints, you could provision your own API gateway using Nginx, for example. I know that's a bummer, because with AWS, you had all in a silver plate for you to use. But, well, that's how Azure works. Always Microsoft doing things at half. Sorry if there is anyone from Microsoft here. And lastly, this shouldn't surprise you because it's a Microsoft product. It runs on top of Windows Server. Oh, sorry, I forgot about one thing that it comes with user experience is that you have an easy third-party authentication. It allows you to easily use Facebook login or Twitter login in order for you to handle authentication for your functions without having your own logic for that. Google Cloud Functions. Oh, I have 40 minutes. I'm going really fast. Okay, Google Cloud Functions are still in beta. It's a new services that just started. But nonetheless, it's a nice services for you to leverage. Like all services, it's event-driven. Unfortunately, it only supports JavaScript for now, and I haven't personally found a way of hacking it to execute on other things, like PHP or Ruby. And I haven't found a way also to use their API gateway. Just like Azure Functions, it provides you one endpoint per function for you to use your own API gateway. And monitoring and logging, fortunately, is already taken care of out of the box by using Google Cloud Stack Driver. That is their service for monitoring and logging. So we're going to move on here. Here are some interesting resources that you could use when it comes to serverless and microservices. The serverless frameworks are yet another isolation layer for you to use with functions. And it gives you the possibility of creating functions in different cloud providers without having to touch anything in any of them. Here you have a few examples. You can find more on the web. And here you have an example of microservices frameworks. Lumen, great framework based on Laravel for microservices. It takes out all the things that we won't use with microservices, and it gives you just a little framework with all the power from Laravel. And if any of you likes Java, Spark Java is a great microservice framework as well, based on Java 8. Great Java version for you to use. And lastly, this was the link I said just earlier for use PHP on Lambda. And you will be able to use Laravel in Lambda with this. Okay, so now we have a few minutes left. I would like to, if anyone has any questions.
Salvação de palmas, pessoal.
Thank you.
This is